Welcome to the next episode in the MERN Plus AI series. Till now, our backend can now refine resumes with AI. But there's one problem, right? It forgets everything whenever it restarts. It's like a sage with wisdom but no diary, right? Every insight vanishes when they sleep. Today we'll change that. We'll give our resume refiner a permanent memory, a library where every resume, every version of the resume will be saved safely even across restarts. That library, that permanent memory is MongoDB, the M in the MERN. Let's get started. Until now, our resumes lived only inside our code, like notes scribbled in a pocket diary. Useful for the moment, but fragile. One restart and they are gone. MongoDB is different. It's a document database, a permanent library for a backend. Every resume becomes a document, structured, safe, and searchable. Why MongoDB? Because it speaks in JSON-like document, the very same language our backend is already using. Because it scales easily from a single user to millions. Because it is a natural M in the MERN stack, working seamlessly with Node and Express. In our resume refiner, MongoDB will hold each user's resume version by version, so no restart or crash erases their journey. Okay, for our database, we'll use a cloud DB, which is called as MongoDB Atlas. It's easier to sign up and get started. So come and search for MongoDB Atlas. Click on the MongoDB Atlas database. Click on Get Started. If you are new, you will have to sign up. Since I already have an account, I'll just sign in with my profile, for which my profile is already set up. Now, once you're signed in, since I already have multiple projects running, you can see different options, organizations, and this and that. In case, since you will be coming here fresh, you will have to start by creating an organization, right? So you'll have to create an organization. And then when your organization is created, the next thing is to create a project. Okay, so let's say I'm selecting this organization. Then I'll have to create a project. Okay, you can create a new project. Give it a name, Tapovan MERN classes, and click on next. Yes, I'll be the project owner. So make sure that your ID is selected. By default, it should be. Clicking on create project. It's all very fast, very easy setup to do. Now, once your project is set up, you're inside your project. The next thing to do is to create a cluster. Okay, it's a you can think of it like a group of server, group of nodes where your database will actually be running. So create a cluster and come to the free tier. For now, we're just learning to get started. I'll not change anything else. Create deployment. By default, it will select the region closest to you and all of that. It will create a database name and username and password. Make sure that you are selecting. I'll just keep a copy of this very quickly for reference later. Now let's come to choose a connection method. Have to create a database user. Yes, then choose a connection method. Right? Now we come to the drivers. We'll shortly install the MongoDB node package. And yeah, this show password you see I'm just toggled it off so that my password is not revealed, right? Earlier they did not used to have the passwords, which is why we need to copy. But now with this option, the entire URL with your username and password is present here. This is the connection URL, folks, that we need to copy. From our node application, we'll pass this URL and our node application will connect to the MongoDB database, the cloud DB. Okay. And of course, where do we keep the sensitive information like this? In the last video, we kept the OpenAI API in the env file. Similarly, this URL also will place it in the env file by the name of MongoDB URI and will use it in our project. Let's do that. Okay, now that we have the MongoDB URL copied in our env file, let us now write code to connect our Node application to the MongoDB cloud database. For that, we'll need the package first, the Mongoose library, which helps us work very easily with MongoDB database. Right, so that is installed. We can do one more thing quickly here is that we are using the required syntax of importing the modules, which is the traditional way, legacy way of doing it, using where we follow the common JS module system. Right, you can read about this. There are two ways of importing: common JS and ES6 way of importing using the import syntax. Right. This also had advantages like you can import packages conditionally and all of that. But there are a lot of newer packages which might give an error saying that required syntax is not defined. You see, this is a common JS module. Okay, it might be converted into ES module. So let us do that. Okay, so what we'll do is we'll come to package JSON. Here you need to pass a property type. Okay, and then you see it gives you two options, whether you want to work with common JS, which is the default, or the module way. So we'll go with module so that we can use the newer way of working with node packages. So we'll have to convert all of this into import syntax. Let us just comment it. I'll just keep it here for reference. Let us import these packages one by one. Import Express from. That is the only difference, right? We just write import something from. Import OpenAI. Okay, import API OpenAI. I think this is not the right import. Import OpenAI from the OpenAI package. Import .env from .env package. What else? The call AI, right? Import the name the function which was called AI from. We'll give dot current folder slash list of the packages. We'll come to the utils and then AI client. We have to give the extension also. I think we are done, right? I will just move this .env to the very top. Generally, we would want the environment variables to be available before any other packages are imported. Let's check this file also. Here also we have the required syntax. Very quickly change it. I think this is where we need the OpenAI, not in that file. We can remove it later. And I don't think we need .env because it is inside the function call. So we'll not need it upfront. Cool. We will not need the OpenAI here. I can just remove this. Wonderful. Now let us write code to use the Mongoose library to connect to the Cloud DB, the MongoDB Atlas. Somewhere here we'll write the method to connect to MongoDB. Now, currently we are writing all our code in just one file. This is not the ideal way of writing code. In a couple of videos later, we'll learn how to structure our code properly using the MVC structure. Okay. For now, just to get everything started, we're using this, writing everything in one place. So the method is Mongoose library and the connect method. Here we need to pass the URL. So process.env and in the environment variable, we had the label MongoDB underscore URI. Okay. Now if you hover over this, right, so let's see if we have imported Mongoose correctly. We did not, right? So we have to import our Mongoose also. Cool. Now Mongoose is imported and the connect method will say that it returns a promise, correct? So we'll use the then block and we'll have a callback. So if everything goes successfully, this callback will run and we will have a console message to confirm that the MongoDB connect. If anything will go wrong, we'll have a catch block. We'll capture the error parameter and we'll just log that as well. Console.error. MongoDB connection error, and we'll log that error object as well also. Right, just with these 2-3 lines, we'll be able to establish the connection, capture the success or the error response from the database. Let us run this. Okay, so server is up and running and we get the message MongoDB connected. Okay, If you want to have a little more confidence that it really worked, the success part also returns a connection callback object. You can log that as well. To see the further details, let us run this again. Node server.js. Now you see the entire connection object returned from MongoDB system. This is like a will give you a lot more confidence, right? We don't need this. It is just to establish first time that yes, indeed, the connection was established. Right? We'll remove this. The pretty big object. You can just go over this at your own in your own code base, right? So now we have built a bridge between our server and the database, right? Every resume that we'll now create will go and get saved in the database. Now let us quickly move towards defining the database structure and start pushing data into our MongoDB. Okay, great. Now that we have connected successfully to the database, to the Cloud DB, the first thing that we need to do is start creating documents because, well, MongoDB, as we've learned, is a document DB. Here, the data is not stored in tables, but in form of documents. But we don't create documents right away. First, what we do is we create the structure required for the documents, which is known as the schema. You can think of it like the blueprint diagram. If you have seen the architecture, when they create the building, before they create the building, they draw the blueprint of that building or of maybe of the house, right? First they identify the material, the size, the number of rooms, what will be the living room, what will be a drawing room, etc., all of that, right? So that structure is determined beforehand, before we even create the actual building. So that structure is what we are going to work now, and that is known as schema, right? So we have two entities in our application right now. We have a resume, and then we have the user for which we will create the resumes, right? So let us define the structure of the user right now in our database. We'll start simple and then we'll keep on adding more properties as the application evolves. So how we create that friend is we say const user schema, we give it a name. Now we'll call upon our friend Mongoose, which we had installed in the last class, and Mongoose will help us create our schema. So we call mongoose.schema. This accepts an object where we define the structure. How we define the structure? We give the properties and the type of the properties. So name, string. Let's say user also has an email. The type again will be string. There are different data types, and I will discuss that briefly. So for now, we'll just take name and email, two properties in my user. The next important entity that exists in our application as of now is the resume itself, right? So let us define the structure for that. So similar pattern, we will do that also. We'll say const resume schema, new, call our mongoose, call the schema constructor, pass the object. Let's say for resume also we have a name, type string. Resume is against a role, type string. Resume is for an experience, this will also be a type string. Resume can contain skills also, correct? And you can have more than one skills. For example, you can have your JavaScript, React, Node.js, and on so forth. So your skills need to be an array of string values. So we'll say skills, and now we'll define an array of string. Right now we're not defining any values, we're just giving it the structure. Like my resume will contain these properties, and the type of values that will be stored in them will be string, string, and array of string. Wonderful. Now I want you to pay attention to one more very important thing. Like for example, if you have worked on relational databases earlier where we have multiple tables, for example, instead of two documents, let's say we have two tables, user table and a resume table. Now what I want is I want to identify that, because when you're creating an application, you will have a lot of users, you will have a lot of resumes also. So what we want to do is we want to map every resume against a user. And if we were working in relational databases, what you know, if you would have worked, is that what we do is we maintain something called as a foreign key. That my resume table will have a user ID, for example. This resume table with the column as user ID will point to the user, one particular user in the user table. That is how we connect two tables, correct? By foreign key pointing to a primary key in the another table. We have a very similar way of connecting two different documents in MongoDB by using something called as a object ID. So what we'll do is in our resume schema, we maintain a user ID property. Now this property will be of type of object ID. So there's one more thing that we are going to learn now, that you can define the property and the type directly, and you can also define it as an object where you can give some more information. For example, I want to say user ID ka type is mongoose.schema.types.objectId, and it will refer to a collection which we'll define shortly called as users. Okay, but this is the only thing that you have to remember, that user ID is a special value or property in my schema which will connect my resume to my user. So there will be a user ID, and this particular resume, one of the resumes in my table, they will point to that particular user. Basically, we're trying to connect the two documents now. When we start populating values for these, then we'll be able to see it better. For now, what I want to show you is the different schema types that exist in Mongoose. You can come to the Mongoose official documentation. You can see that we can have a string type, we can have a number type. For example, let's maintain a version also. Let's say we'll keep making changes to our resume and we want to maintain a version of those resumes. So that type can be a number type. A date, boolean, object, that is what we have used, right? So let me show it to you very quickly. So for example, let's see, I told you that we can have the value and the type directly. We can also pass an object. For example, look at this. In this updated property, we are saying type is date and default as date.now. So you can give default values, you can give minimum and maximum. Basically, with these object class structure, you can give some additional validations, some additional conditions that your data types that your data should follow. Correct. For example, again, if you go to SQL, if I take you back to SQL, we used to have a lot of conditions that only numbers can be entered for this column. Only a particular type can be, or a particular range can be added in this column. So that is what we're trying to enforce here. Similar concept, but with a different structure. Okay, we'll explore all of these as our complexity grows. But for now, we'll just keep it very simple for now. All right. Now our backend has a very clear grammar, schemas that define the structure that shows what exactly how your document will look like when you look this in the database, right? But before your database can truly remember, you have to give these blueprints a name. So first step to defining your database is you give them a structure. The next step is to create a model using the same schema. So let's do that very quickly. We have a user schema. Now what we'll do is we'll define a user model. Okay. So what we do is we create a constant, we give it a name, we call our Mongoose friend again, this time the model method. We give it the name of the collection. So I'm saying that, hey, I want a user collection and please create this using user schema. Okay. Again, what we are doing is schema is just a design. Schema is just a blueprint. The model that we have created is the living form. When we call mongoose.model user schema, what we're saying is, hey MongoDB, create a collection named users. Later, when we see that data actually being saved in the MongoDB database, we'll see that the user actually becomes users. What MongoDB does is it makes it lowercase and pluralizes it. So we'll see a collection of user, and by the name of users that will be created using the blueprint user schema. Correct? So again, let me help you draw this picture. Users table will be created. Inside the table, each record will be a user, actual user, with the structure that with containing the name and email. So the columns will be name and email. If we look at the table structure, if you look at the SQL structure, the corresponding SQL structure will be a users table will be created, and every record will be a user record. The columns will be name and email. But again, in MongoDB, we don't talk in terms of tables, we talk in terms of documents. So here what you're doing is a collection of user document will be created, and each document will follow the structure defined in the schema. Okay, let's define the model for resumes also very quickly. We'll say const resume. Mongoose, please create a model, resume model using the resume schema. All right, so same structure, okay, same pattern here. We'll take the blueprint of resume, all right, and breathe life into it. Every time a new resume is added, Mongoose will create a new document inside the resumes collection. So this is resume singular. MongoDB, when we'll see, it will get a collection which will be resumes, right? Where each resume, each document will have these properties, where it will have name, roles, experience, skills, version, and a user ID, which will correspond to the entry, one of the entries in the user schema collection, in the user collection. Right, I hope this makes sense. In the next video, what we'll do is we'll bring these models into action. Now that you have models in place, with these models, we'll do the CRUD operations. We'll create a document, we'll save a document, we'll find and update a document, we can delete a document. So all these operations which we have been doing in a hard-coded manner using our arrays will start interacting with databases and persisting that data in the database. So please wrap up your code till now. Comment in the sections, drop a comment that you have completed, and we'll continue the journey of the CRUD operation in the next video. All right, see you. Thank you.